uh, two as well. So, all right. So let's get started. Okay, this is 10.5, counting problems involving not and or. And our objectives, we're going to understand complements of principal counting, apply complements of principal counting to problems that involve not, understand additive principle of counting, apply additive principle of counting to in terms of union with or statements in it. So counting problems involving not, basically thought of as indirect. So basically with problems involving not, like if you wanted to look at a deck of cards that did not have aces in it, then you would consider 52 cards in the deck. Well, there's 4 aces in the deck, so you would subtract 4 from that. Okay, so in your notes, I left blank the complement, the symbols in this. So complement is like apostrophe. With a connective symbol in a secondary, whereas operation, when we're talking about union, we use the word U. For logic, it's a tilde for not, P or not P, for example. For connective, such as adding, we use the V looking symbol. So for arithmetic, we subtract. For complement, addition, we use the plus sign. So these are different symbols that we use between logic and arithmetic. Okay, now in on this, basically it's problems involving not. You have we have a Venn diagram here where the universal set includes all, everything that's involved in what we're talking about. Whereas set A equals something, and its complement would be not set A. What does all that mean? If we and if we were to have this diagram and in we have numbers, let's say 1 through 10. Okay, and let's say set A, our numbers are all even numbers. So 2, 4, 6, 8, 10. So this is set A. So the complement of that would be all the numbers that are in the union but are not in set A. So that would be 1, 3, 5, 7, and 9. So it's all the elements in the union that are not in set A. So that would be the complement of set A. So if we were to say the number in set A plus the number in the complement equals to the total number in the union set. And that's what this is saying here. Okay, that's what this is saying. So if you took number in A, set A, that would be the union minus the complement. All right, so that's another way to write that. So the complements for in your notes, you would write in here n. The n means the number of elements in set A equals to the number of elements in the universal set minus number of elements in the complementary set. And you could also say that the numbers in the complement set equals to number in the union minus the number of elements in set A. So you could also say it that way as well. All right. Questions there? So, all right. Any questions? Okay. Counting proper subsets are basically you take the number of a proper subset has less than 7 elements in it, satisfy the condition. So basically with a proper subset, you take 2 to whatever power you have in that element. Okay, so in this case, you have calculators 1, 2, 3, 4, 5, 6, 7 elements in it. So the number of subsets so if we were to look at our board, subsets is 2 to the n power, where n is the number of elements. Number of elements in the set. So if we were to take, so since there's 7 elements in calculator in the set with the letters calculator in it, 1, 2, 3, 4, 5, 6. Hold on. Okay, they don't repeat. So it's C-A-L-U-T-O-R. There's no A. Okay, see, they have C-A-L-U-T-O-R. So it's now 1, 2, 3, 4, 5, 6, 7. So we would say that n has 7 elements in it. So to find the number of subsets, you take 2 to the 7th power, right? 2 and then exponent. Where's my exponent button? Here it is. 7th power is 128. But this includes, when we're talking about subsets, we mean like C-A-L or C-A, C-A-L, C-A-U. But this also includes the original set. So proper subsets does not include the original set, a subset that includes all the elements in it. So that would make it, so to find that, use 2 to the n minus 1. So since 2 to the 7th is 128, 128 minus 1 would be 127. So there's 127 proper subsets. All right. So to find the number of subsets, use 2 to the n, where n is the number of elements, right? But subsets include things like C, right? You can use C or A, right? Or L, or you can use CA or CL. So you can use a lot of different combinations of subsets, right? Well, a subset is also all the elements, right? CALUTR would also be considered a subset, but it's not considered a proper subset because the proper subset doesn't include the subset with all the elements in it, like the original set does. Okay, so that's why we subtract 1, all right, to get the proper subset, all right? So that helps us figure out how many, combinations we can get at times. So we have, if 5 fair coins are tossed, how many ways can at least one tail be obtained? So basically, if you're looking at this, right, we have 5 coins, right? So we have coin 1, 2, 3, 4, 5. So each one of these could either get a heads or a tail, right? Heads or a tail, heads or a tail, heads or a tail. So we want to know how many ways can you flip 5 coins. How many ways can at least one tail be obtained? Well, so in other words, we're talking about either a tail, heads, 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 right? Or heads, heads, tails, heads, heads, and so on. So basically, that would be 2 to the 5th, right? Since there's 5 coins. And that would be 2 to the 5th, would be, I believe that's 32. Do this real quick. That's 32, yeah. So that's 32. But we want where at least one tail would be obtained. So we would subtract 1 and get 31. Because what's the one that's being subtracted? The one where they're all heads, right? So if at least one tail is obtained, you cannot include the one that has all heads in it. That's why you're subtracting 1 from it, okay? All right. And so that's how we get 31. Okay. Any questions with that? Okay, another problem with counting sets is where we have or. And with or, you can run into the problem of counting something twice. Like, for example, if we have this deck of cards, right? And so we have this deck of cards. Let me show this. So here's a deck of cards, right? And so we want to know what is the possibility of picking an ace of diamonds, right? Well, the problem with that is you've got diamonds, hearts, spades, and clubs. And you've got ace, 2, 3, 4, 5, jack, queen, king, right? And so you've got ace to all the way down to jack, queen, king. And same thing with the spades, ace to king, and club, ace to king. So we would look at a number of ways of selecting an ace plus the number of ways of selecting a diamond. So here's diamonds, right? There's 13 diamonds, and there's 4 aces. But the problem with this is the ace of diamonds would be counted twice. So we have to subtract it from the overlap, diamonds and an ace, which there's only one ace of diamonds in there. So 13 plus 4 is 17. 17 minus 1 is 16. So there's 16 different ways of selecting either an ace or a diamond. Okay. So what's that? Yeah. Now, if we want to know how many ways can we select an ace or a diamond? An ace or a diamond. Okay. So, because we can pick a card, right? We can pick a card and it can be a diamond, right? Or we could pick a card and it can be an ace, right? So there's 4 aces in a deck, right? And there's 13 in each deck, in each suit, right? 13 diamonds, 13 clubs, 13 hearts, 13 spades, right? So there's 13 different 13 different diamonds we could select, right? But there's an ace of diamonds. Okay, so there's 13 diamonds, right? Ace through king, and there's 4 aces, but the problem is the ace of diamond can be counted twice, as an ace and as a diamond. So we have to, we count the number of aces as 4, plus the number of diamonds is 13, but we have to subtract the overlap of ace of diamonds, or an ace and a diamond, which there's only 1. So there's 4 aces and 13 diamonds, so that's 17, and there's only 1 ace of diamonds, so we have to subtract that. 17 minus 1 is 16. Okay? All right. Okay, so that's when we have an overlap. So this would be considered, so if you're finding the probability of 2 items, selecting 2 items that are disjoint, like selecting a diamond, or let's do this. It's easier if I erase it this way. Let's say we wanted to find the probability of selecting either an ace or a jack. Well, there's no overlap there, right? So this would be considered disjoint sets. Disjoint sets. And disjoint is where there's nothing in common. So nothing in common between, in this case, an ace or jack, right? It's kind of like when you meet a girl, okay? And you're going to have, maybe you'll have some things in common. Maybe you won't. Maybe you both like music. You know, maybe you like soul music, or maybe you both like soul food. Okay, so you got something in common, right, with that girl. You go out with a different girl, and you don't have a single thing in common with this girl, right? That would be like a disjoint set, right? You neither one of you like soul. She likes soul food, or you like soul food. She doesn't. You like soul food or soul music. She doesn't. You know, and nothing in common. So that would be like disjoint sets. Okay. All right. So when the sets are disjoint, then you don't have to subtract. So in other words, in this case, if we're looking for the number of aces, or jacks, right? Then that would be the number of aces plus the number of jacks. And since there's no overlap, right, you don't have a jack of ace, right, then you don't have to subtract. So the number of aces, how many aces are there in a deck? 4. How many jacks? Also 4, right? So there's 8 different ways to select either an ace or a jack. Okay? So another way to look at it is at disjoint sets with a deck of cards is, let's say we wanted to select either a heart, okay, or a club. Well, you don't have a club of hearts, right? There's nothing in common between, there's nothing that's the same, that has 2 of the same thing in it. There's no card that has a club and a heart in it, right? So if we wanted, these would be considered disjoint sets. So if we wanted the number of clubs or hearts or clubs, I said, hearts or clubs, then that would also be disjoint because there's nothing in common. So that'd be number of hearts plus the number of clubs, right? 13 hearts in a deck, 13 clubs in a deck. So how many is that? 26. So there's 26 different ways of picking a card, right, from a deck and selecting a heart. Okay, any heart, don't matter which one. All right, what questions with that? Okay, so that's what we mean by joint or disjoint or not disjoint. Okay, any questions with that? All right, how many 5 cards consist of all hearts or all black cards? All right, now with this one, you have How many 5-card hands consist of all hearts or all black cards? Okay, so what you're looking at here is, since order doesn't matter, right? You have a combination of the number of hearts. So how many hearts are in a deck? There's 13, right? And how many are in a hand? 5, right? So we're talking about how many 5-card hands, right? So basically 1, 2, 3, 4, 5, right? How many 5-card hands are going to have, and what we want here is how many 5-card hands consist of all hearts or all black cards. So we look at a combination of all hearts, right? So we're looking at a combination of all hearts or all black cards. So we want a combination of all hearts or black. Okay, so you have a combination of 13 hearts, taken 5 at a time, plus a combination, well, if there's black, right, there's how many black cards in a deck? Well, there's clubs and spades, right? So there's 13 clubs and 13 spades, so that would make it what? 26. Again, taking 5 at a time, right? So that's what we're talking about here. And so from here, so there's no black heart, right, in cards. So we don't subtract anything. So we find a combination of hearts, right? 13 taken 5 at a time, plus black card 26 taken 5 at a time. So you can do this all on the calculator all at once. So you would put in, first you would put in 13. Let's turn it on. First you would put in 13, and then go to PRB and select combination, and then 5, okay, and you get 1287. So we've got combination of 13, take 5 at a time, you get 1287. So now we're looking at black cards, right? Combination of 26, taking 5 at a time. So we do the same thing. Now we're going to put in, clear that, put in 26, PRB, hit combination, taking 5 at a time, and we get 65,780 equals 65,780. So we add these two together, 1287 plus 65,780, and we get, so basically we just take this 65,780 and hit plus 1287, and we get 67,067. So there's 67,067 different ways to have a 5-card hand that has either hearts or black card in it. Okay? Questions with that? Okay. So, example of a counting delegation from a counting selections from a diplomatic delegation. Okay, diplomatic delegation of 20 congressional members are categorized as a political party and gender. If one of the members is chosen randomly to be a spokesperson of the group, how many ways could that person be a Republican or a man? So, you look at the number of Republicans and the number of men. So there's 12 Republicans, right? Now, if I were to rewrite this, okay, you've got Republican, Democrat, and total. And you got men, woman, total. Okay, so there's 8 men, 4 women, 12 total, right? And men, there's 8, 3, and 11. So we want to know if one of the members is chosen randomly, how many ways can that person be a Republican or a man? So we want to know the number of ways. So we want to know the number of ways it can be a Republican or a man. Well, here's the number of Republicans, right? And here's the men. So do we have an overlap here? We've got Republicans, we've got men. Yeah, we've got male Republicans, right? So male Republicans would be counted twice. So we look at the number of Republicans plus the number of men, but we have to subtract the number of male Republican, or number that's both a Republican and a male. So would we say these are mutually exclusive or not mutually exclusive? Not mutually exclusive, right? Because you can have a Republican male, right? So you look at the number of Republicans, right? There's 12. So there's 12 Republicans, and you look at the number of males, which is 11. And then you look at the number of male Republicans, which is what? Male Republicans. So 4 would be 8, would be 4 women, right? So it would be 8. So 12 plus 11 is 23, right? Minus 8 would be what? What's 23 minus 8? 15, right. So there's 15 ways of selecting either a male or a Republican. Okay? Questions with that? All right. Let's try this again. What would be, how many ways can you select a female or a Democrat? Okay? So let's go back to our chart. Women, we have 5 and 9, and Democrats 3, 5, and 8. Okay. So how many women do we have total? 9. So you got 9, right? You're looking at women, and you're looking at Democrat. So are these mutually exclusive or not? Not mutually exclusive, right? You got an overlap. So you would put in here number of females, right? Plus the number of Democrat. But we would subtract what? Number of female and a Democrat, right? Female and a Democrat. In other words, it's whatever you're adding here, that's what you put here with and in it. It's the same. That's the same thing here. Republican and male Republicans, right? Republican and a male. Okay, so what do we put for number of females? 9. Okay. And how about the number of Democrats? 8, right. 8 total Democrats. Minus female Democrats is 5, right. So 9 plus 8 is 17, right? Minus 5. So how many different ways can we select a delegation of either females or Democrats? 12, right. Okay? So that's how that works. Okay. So that was the one for the males and the Republican. I added the female and the Democrat just for extra practice. All right. Okay. So how many 3-digit counting numbers are multiples of 2 or multiples of 5? So all right. Okay, we have how many 3-digit numbers are multiples of 2 or 5? Of 2 or 5. Okay, so so we have 3 digits, right? Digit 1, digit 2, digit 3. And so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? But we don't count 0 in the first digit, right? We don't say 0, 23, right? We just say 23. So we don't count 0 in the first digit. So that means we have a total of 9, right? And so the second one is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That would be 10 in it, right? And the third digit is also 10. But if we're looking at multiples of 2, right, then 0 is you have to look at the last digit. The last digit has to be even. So the last digit can be a 0 or a 2 or 4 or 6 or an 8. So that would be 1, 2, 3, 4, 5. different last digits you could have to get a multiple of 2. So that would be, if you took 9 times 5, that's 45. 45 times 10 is, you just add a 0 on the end, that would be 450. Okay? Okay, so that would be for number of multiples of 2 for a 3-digit number. Multiples of 5. Well, in order to be a multiple of 5, what does the last digit have to be? A 0 or a what? 0 or a 5. So really, that's only how many at the end? How many last digit numbers can we have? 2, right? So now that makes it 2 times 9 is 18 times 10 is what? 180, right? You just take 18 and add 0. All right? Yeah, you can't have 0 in the first column because we don't look at 3-digit numbers with a 0 in front, right? That's not considered a 3-digit number. That's a 2-digit number, right? So that's why we don't count 0 in the first digit. You can have 0 in the second digit, right? Or you can have 0 in the third digit, but you can't have 0 in the first digit because that's not a 3-digit number. That's only 2. That's why 0 is not included in the first digit. Okay? All right. Any other questions there? Good question.
Can I see the top of the chart, please?
Yeah. So this would be digit 1, right? Digit 2 and digit 3. Okay? So the book doesn't get too much into doing it this method, but I like using this method because you can see all the numbers right in front of you, and it just seems to work better. Okay, any other questions there? Okay, so let's go to the next one. A single card is drawn from a deck of 52 cards. How many ways could it be a queen or a club? A queen or a club? So we're talking about selecting a queen, number of ways of selecting a queen or a club, right? So we're talking about selecting, there's a queen, right? Or there's a club, right? Well, so we've got number of ways of selecting a queen plus a number of ways of selecting a club. But do we have an overlap? Do we have something that has both in it? Queen of clubs. Is it possible to have a queen of clubs? Here's clubs, right? Ace, 2, 3, Jack, Queen, King, right? There's 13. There's 13 clubs, right? And so there's clubs, spades, hearts, diamonds, right? But you also have a queen You have a queen of clubs, queen of spades, queen of hearts, and queen of diamonds, right? So you have 4 queens and 13 clubs, right? Is this mutually exclusive or not mutually exclusive? It's not mutually exclusive, right? Because you got an overlap. You got one that has both in it, queen of clubs, right? So what do we have to do here? Minus, yeah, we got to minus the number of queen and a club. So the number of queens is 4, plus the number of clubs is 13, and there's only one queen of clubs, so that's total 16. Okay? Questions there? Okay. How many ways can it be a red card or a base card? Red card or a base card? Okay, so we're talking about a red card, right? Or a face card. So do we have any red face cards? Yeah, we do. Here's one right here, right? So we're going to have to subtract. Yeah, we're going to have to subtract, right? So we're talking about the number of ways of selecting a red card, number of ways of selecting a red or face card. So we want the number of red cards plus the number of face cards. But we have, do we have red face cards? Yeah, we do. So we got to subtract the number of red and face cards, right? Well, here's clubs, spades, diamonds, hearts, and there's ace, 2, 3, 4, jack, queen, king, right? I'm going to make this smaller so that I can get the whole thing in there. Jack, queen, king, right? So each one of these are the same. Ace, 2, jack, queen, king. Ace, 2, jack, queen, king. So we're talking about red, right? So red would be what? What suit of red? Well, hearts is red, right? What else is red? Anything else? Diamonds, right? So diamonds and hearts are red. Okay? What would be considered a face card? Yeah, a king, right? A jack and a queen. So we just need a red card or a face card, right? Well, how many face cards do we have total? So we're talking about 13 diamonds, 13 hearts. That's going to be 26, right? How many face cards are in each suit? There's jack, queen, king, jack, queen, king. Yeah, there's 4 suits, and there's 3 in each suit. So how many face cards are there? 12, right? So we're talking about 26 red, 12 face, But how many red face cards are there? Red, yeah, there's 6 red face cards this time. So this would be 26 plus 12 minus 6, right? Well, 26 minus 6 is 20. 20 plus 12 is what? 32. Okay? So this time, there was more than just one overlap. There were 6, right? Okay. So that's 32 different ways of selecting either a red or a face card. All right, questions with that? Okay. All right, on this, let's go to this. Two fair dice are rolled. How many ways can the result? One die shows a 2, right? So if we got 2 dice, okay, we have 2 dice here, right? And one of them, we roll them both, and one of them is a 2. So how many other ways can we select the other dice? 2 fair dice are rolled. How many ways can the result be obtained where one dice is a 2? So the other dice would have to be either, so if one dice is a 2, right? Here's dice 1 and die 2. If one of them is a 2 and the other one is a 1, a 2, a 3, a 4, a 5, or a 6, right? How many different ways can we roll the first dice? If the first dice is a 2. It's just 1, right? It's just the 2. But how many ways can the second dice be rolled? 6, right? So 1 times 6, here's N1 times N2 again, right? So it's 1 times 6 is 6 different ways to roll 2 dice where the first one is a 2. What? Because we're saying, all right, if we roll 2 dice and one of them we already rolled as a 2, right? We know that one's a 2. We want to know what is the other dice going to be. So if we're saying, okay, I'm thinking I'm going to roll a 2 on the first dice, but I don't know what I'm going to roll on the second. So that's why the first one is a 1. Now, if we were to say, what if I roll either a 2 or a 5, right? 2 or a 5 on the first dice. Now that would be 2, right? And that would make this 2 times, and 2 times 6 is 12, right? Okay? So that's why that first one was a 1, because we're saying, all right, what if the first dice is a 2, but we don't know what the second one is, all right? Okay. The number is what? Oh, yeah, sure. Okay. So for the second one, we want to know how can we roll 2 dice and the roll is not a 7. Well, if we have die 1 and die 2, And die 1 has 1, 2, 3, 4, 5, 6, 7, or 6 in it. And the other way is 1, 2, 3, 4, 5, 6. So 7 can be a 1 and a 6, right? Or a 6 and a 1, right, for 7. Or it can be a 2 and a 5, right, or a 5 and a 2. And the next one is a 3 and a 4, or a 4 and a 3. And so you got 1, 2, 3, 4, 5, 6 different ways of rolling a 7. If there's a total of 6 times 6, total is 36, right? Then it'd be 36 minus 6. There's 30 ways of rolling 2 dice that's not a 7. Okay? Questions there? What? Oh. Okay, the sum of 2 dice with at least a 5. With at least a 5 in it. So another way you can do this is the sum of 2 dice is at least a 5. At least a 5. So you've got a 1 and a 1, right? A 1 and a 2, or a 2 and a 1. A 3 and a 1 and a 3, right? Or a 3 and a 1. 1 and a 4, or a 4 and a 1. Well, can we go any higher? 5 and 1, no, because that's a 6, right? So you've got 1, 2, 3, 4, 5, 6, 7. 7 ways of rolling at least a 5. Okay? So that's another way to roll at least a 5. Okay? All right, questions there? Okay, so that's 10.5. Okay. Any questions with that? All right, now let's take a look at the